So we are studying op amps, and so far we have seen two important properties of op amp, or two important rules. So rule number one is this input output relationship, which says if Vp is higher than Vn, Vp and Vn are the two inputs, then the output will be positive, else output will be negative. This we also have represented graphically, pictorially, like this, which we call the static characteristic. So this is rule number one. And then we have seen rule number two, which is here, which says no current can go into or out of this input terminals, either of these input terminals of an op amp, which is same as saying the input impedance is infinite, because whatever voltage you apply, current will be zero. So these are the two important rules, and I already have said that these are the two rules with which you can do almost anything you want with ideal op amps. Okay, any op amp based problem you can solve, any op amp based circuit you can analyze with just these two rules. So today we will see three important circuits, three very popular and common circuits, amplifiers with op amps. So amplifier circuits with op amps. So we will see three of them, namely we call them difference amplifier, inverting amplifier, and non-inverting amplifier. So these are the three circuits that we will study. Okay, so let me draw them first. Let me first draw the circuits. So let me make three columns. Okay, so first let me draw the difference amplifier. So this is the op amp. We will have minus and plus inputs, one output, two inputs. Okay. Okay. So for the beginners, who are studying op amps for the first time, before we understand them physically, we will definitely understand them. But before that, it may be a good practice, at least for some students, to just to identify a common structure between the three amplifiers we are going to see. So the common structure is like this. So I will write this common structure. Okay, you can remember it like with this rule. This is my thumb rule, NOPG. Okay, so which means negative should be connected to output, N for negative, O for output, P for positive, and G for ground. So what you have to do, you have to connect the negative input, which is here, connect it to the output through some resistance. Okay, then you connect the positive one to the ground. So let this be the ground terminal, or reference 0 volt terminal. So this is output VO, this is VN, negative connected to output and positive connected to ground. Okay, so this is the rule, NOPG. Okay, So negative to output, N to O, positive to ground, PG. That's all. That's all you have to remember. And this is called the difference amplifier. Why is it called difference amplifier? Okay. So it has two inputs. So this two will act as the input of the overall circuit. So this is my overall circuit. It has two inputs and one output. Okay, so the way it works is very simple. So if you apply, say, two voltages, call it V1 and V2, the output, call it VO. Okay, output VO will be a function of the difference of these two inputs. Okay, V2 minus V1. Why 2 minus 1? Because 2 is connected to positive side and 1 is connected to minus side. Okay, so therefore plus 2 minus 1, V2 minus 1. This multiplied by some factor K, and this K we will call it the gain or the amplification factor. Gain or amplification. Okay, so this is how a difference amplifier looks like. You just have to remember this rule, NOPG, negative to output, positive to ground. And how it works or what it does, it gives the output which is proportional to the difference of the two inputs. So this is the rule, input output relationship. Okay, so this is difference amplifier. Now next, what we will do, I hope so far you have understood. So just two things we have said: how the circuit looks like. For now you just memorize it. Okay, and what it does, what is the functional rule, output input relationship. Okay, so these are the two things we have said. Now this is difference amplifier. Now we will copy this here. Now what we will do, say we will connect the V1 to ground. Okay, so we will connect this terminal, say, to ground. Okay, so V1, that means V1 is equal to 0. So then what will happen? This is the same circuit. The only difference is that instead of applying a voltage V1, I am just applying 0 volt. So here, therefore, I can definitely write the output will be K times V2 minus 0, which is same as K times V2. Okay, or V2 is same as Vp. So you can also write K Vp here. So this is the rule. And here you see the output depends only on one input, because the other input is constant, fixed. So this has only one input. Okay, because the other one is constant, it's not changing. But this circuit has two inputs. You can change both of them. Okay, here I have made one of them constant. That's the difference. Okay, and so this is called a non-inverting amplifier. One small thing I have missed, sorry. So this is another thing you should note. Okay, we should have resistances everywhere. Then we will eliminate some of them later. So this point is Vp. This point, sorry, this is Vn, and this is Vp. Here also let me put this resistances first. So this is Vn, this is Vp, negative and positive. And right now I haven't written the values or any name of these resistances. I'll do that soon. Okay, or let me do it. So you also remember that the resistances should occur in pairs. If this one is R1, then this one should also be R1, same value. If this is R2, then this should also be R2. So similar resistances like these two, which are connected to the inputs, they should be same, and the other two which are not connected to the inputs, they should be same. Okay, so this is another important thing which I missed. Here also let me now then put the values R1, R2, here R1 and R2. This is called non-inverting amplifier. Why is it called non-inverting amplifier? Because the output depends only on one input, and it simply is the product of some factor constant times the input V2. And if V2 is positive, output is also going to be positive. That's why it is called non-inverting. Okay, now you observe one small thing, which is this. So I'm giving input V2 here, and so therefore some current will flow, and it will flow like this. It will start from here and will go to ground. No current can go through this input. That's rule number 2, right? So the current will go only like this. No current can go to or out of this input terminal. Therefore, the potential at this point, which is Vp, okay, so Vp is, we can therefore write Vp using potential divider rule is V2 whole divided by R1 plus R2. Okay, so this is what? This is nothing but I. Okay, this is equal to I. Then multiplied by R2. This is the potential difference from here to here. Okay, this is Vp, and this is equal to I, current, this current. Okay, so this is Vp. So therefore now we can see that VO is what? VO is K times V2. Now in place of V2 we can write this. So K multiplied by, in place of V2 we write Vp multiplied by this divided by this. Vp divided by R2 and R1 plus R2. Okay, so then you see that, let me write it this way. Let me write R2 here and Vp here. So you see that this and this both are constants multiplied by Vp. So therefore we can write this is equal to K1, where K1 is this multiplied by this times Vp. Okay, so what is happening? What is happening is this. So the voltage that we are applying here is getting reduced by some factor at this point, by a factor of R2 by R1 plus R2, potential divider rule. So this voltage is first getting reduced or what's that called, opposite of amplification, attenuated. Okay, so the voltage is first getting attenuated at this point, and then it is getting multiplied by a factor k, and this is the output VO. So in this circuit we therefore have first attenuation. So this part okay, so this pink part is an attenuator, and the final output is, we see that it is V2 multiplied by VO. So we can say that the input voltage is first getting attenuated and then getting amplified by the rest of the circuit. So the rest of the circuit is an amplifier on its own, is an amplifier on its own. So the rest of the circuit is therefore an amplifier. So what we can do, we can eliminate this part. Okay, so therefore we can eliminate the this attenuator or potential divider, and it will still be a amplifier because the rest of the circuit will do the amplification. So what we do is this. Let me copy it. Okay, so now what I will do, I will simply remove this part and connect the input directly to Vp. Okay, so let's remove this part, this potential divider completely. And connect the input directly to Vp. Okay, this is and this is not there. So this will also act as an amplifier. And you might have already seen this circuit in books or elsewhere where it is written as the non-inverting amplifier. So it is non-inverting amplifier, but it is not much different from the difference amplifier. So what we have done, or what I want to say you is that you do not have to remember three different circuits for difference amplifier, non-inverting amplifier, and the another one I will do is inverting amplifier. You just have to remember only this one. Remember only this circuit. Okay, remember only this circuit, difference amplifier, and from this you can find out the other two variants, non-inverting amplifier and the other one that I will do, inverting amplifier, quite logically. Okay, what is the idea? So it has two inputs, and you make one of them 0, you make V1 equal to 0, say, then you connect it like this. then this circuit becomes like this, and then you observe, okay, this is nothing but a potential divider. Okay, so the input is first getting reduced and then getting amplified. So why, I mean, if I just want to amplify, why do I need this attenuator? I can connect the input directly here. So that's what we have done. So then it becomes the standard non-inverting amplifier which you might have seen in books. Okay, you do not have to remember it separately. Now let us see the inverting amplifier. Once again we will derive it from the difference amplifier. How? I will copy it first. So this is difference amplifier, okay, and here the output is k times V2 minus V1. Now we will make, say, V2 equal to 0. Previously we made V1 equal to 0 for non-inverting amplifier, but now we will make V2 equal to 0. Okay, so let's make V2 equal to 0. Okay, so that means we will connect it like this. Okay, if we do so, then the output VO will become K multiplied by V2 is 0, so 0 minus V1, so this will become minus K V1, right? So you observe that output is proportional to input 1 and it's opposite to input 1 because of this minus sign. So if output is positive, input is positive, output will be negative, and vice versa. So therefore it is called inverting amplifier, because the sign of the output is inverted. This is called inverting amplifier because of this minus sign. Here there was no minus sign, that's why it is called non-inverting amplifier. Okay, K is a positive number. Okay, so K is positive. Okay, great. So now you see, so this is the circuit which we have derived from the difference amplifier. Now can we simplify this circuit? So like we did some simplification from here to here, can we also do some simplification here? Yes, you see that this point is at 0 potential. This point is at 0 potential. So what will be the potential here? Somewhere in between 0 and 0. Once again you can apply potential divider rule. Okay, so here Vp will be 0 because this is at 0, this is at 0. Vp is somewhat halfway between 0 and 0. No current is flowing in this part through the input. That's the rule of an op amp. Therefore Vp must be between V2 and this ground. V2 is 0, this is also 0, so Vp should be 0. So therefore this point is at 0 volt. Okay, so this is at 0 volt. Now if this is at 0 volt, why do I draw it with two resistances like this? Why do I not directly connect this point to ground? I can do it. So let me just do that. So let me copy paste so this is the circuit. I know this is at 0 potential, so why do I need this? I can directly replace this with ground. Similarly, I do not also need this. So it's gone. This is Vp. Okay, so this is equivalent to the previous circuit. So these two circuits are equivalent. Okay. So, and this is the circuit that you have possibly seen in books or elsewhere. So here, okay, so let me let me just recap this topic. So far we have seen 3 circuits, and their names are difference amplifier, non-inverting amplifier, inverting amplifier. What do they do? Say this non-inverting amplifier, this has finally one input and one output. An output is some amplification k times the input. What does this do? The output is this input V1 multiplied by some negative factor minus. And what does this do? This has 2 inputs. So therefore output depends not only on V1, not only on V2, but on both of them and on the difference between V1 and V2. V2 is connected to positive, so V2 minus V1, this multiplied by some factor k will be the output. This is called difference amplifier. This is how it works. Okay. Now how to remember this? You just remember only one circuit, difference amplifier. How to remember? Remember this rule, NOPG. So draw the op amp, connect the negative terminal to the output, N to output, positive to the ground, P to G, put resistances everywhere, here, here, and also this 2 will be the inputs, put resistances, here output. Okay, do not put resistance here at the output. Okay, and you just remember that the similar resistances like this one and this one, which are connected to the 2 inputs, should have same value R1 and R1. The other 2 resistances also should have same value R2. So this is how to remember the circuit. Okay, so next we shall see the circuit theory of these 3 circuits. Okay, so let's take a break. Thank you.